If we look at section 8.4, we're learning about compound interest. And this is interest that's computed on the original principal as well as on any accumulated interest. Our formula for calculating compound interest is a little bit different than what we saw for simple interest. So if we're calculating the amount in an account for compound interest paid n times a year, we use the formula A equals P times the quantity 1 plus R over N raised to the power of N times T. So we've seen most of these variables before. A still stands for future value, P still stands for principal or present value, R still stands for the rate in decimal form, and T still stands for the time in years. Now N is our new variable, and N is the number of times per year that interest is computed or compounded. So we need to know some vocabulary to help us figure out our N. If it's annual, N equals 1. If it's semi-annual, N equals 2. If it's quarterly, N equals 4. If it's monthly, right, there's 12 months in a year, so it would be N equals 12. If it's weekly, there's 52 weeks in a year, so it would be N equals 52. And if it's daily, for the purposes of our textbook, remember they told us to assume that there's 360 days in a year, so we would say N equals 360. So let's look at an example. It says you deposit $1,200 in an account paying 3.2% interest compounded once per year. How much money will be in the account after 5 years, and find the interest earned? So because we see this word compounded, we know we need to use a formula dealing with compound interest. The only formula we know that deals with compound interest so far is A equals P times 1 plus R divided by N, all raised to the power of N times T. So just like I did before, I'm going to list out all the variables and I'm going to read through the problem and see what I can find. So they told me that I deposit $1,200, that's my principal, in an account paying 3.2% interest. So that's our interest rate in percent form. I take that 3.2 and divide by 100 to get 0.032 in decimal form. They tell me that it's compounded once per year. So that once per year is telling me that my N equals 1. And they're asking me how much money will be in the account, so that's my A, after 5 years. That's my time. All right, so I'm going to substitute everything in. A equals the principal, $1,200, times 1 plus the rate, 0.032, over N, which is 1, raised to the power of N, which is 1, times T, which is 5. Now I realize there's a lot of ones here, but I want to model how to put this in the calculator even though there's a lot of ones for when those numbers are different. So when I'm using my Desmos calculator, I'm going to do 1,200, open up a set of parentheses, 1 plus 0.032 divided by 1. I'm going to hit the right arrow to get out of the fraction, and I'm going to close the parentheses. Now I need to get an exponent. So I'm going to hit this button that's in the top middle on the left-hand side that says a to the power of b. So it puts me up in the exponent. I need to open up parentheses again. I'm going to do 1 times 5 and then close my parentheses. So I get the answer that the future value is 1,404.687548. Just like before, they could ask us to round to the nearest cent or to the nearest dollar. So if they asked us to round to the nearest cent, that 7 tells us to bump up. So we'd have $1,404.69. If they asked us to round to the nearest dollar, the 6 also tells us to round up. So we'd have $1,405. Now that's the answer to the first question, how much will be in the account after 5 years? So this is how much will be in the account after 5 years. They also ask us to find the interest earned. Now notice, if we look back up at our equations for compound interest, there's no I, right? There's no interest. So we have to use what we already know. We learned before that that future value was the same thing as just the principal plus the interest. So that means that our interest, if we're trying to get that by itself, we can subtract the p from both sides. So that means that our future value minus the principal is what gets us the interest. So in any of our compound interest questions, when they ask us for the interest, we're going to take our future value and subtract out the principal. So let's round to the nearest dollar for this answer. So I would take the future value that I solved for, round it to the nearest dollar, the $1,405, and I would subtract out the principal from the problem, the $1,200. If I do that, 1,405 minus 1,200 tells me that the interest is $205. Let's look at number 2. They tell us that we deposit $6,500 in a savings account that has a rate of 7%. The interest is compounded monthly. How much money will you have after 4 years? And find the interest after 4 years. So they're telling me that it's compounded monthly. That's my clue that I'm using compound interest because we have that word compounded. So I know I'm going to use my compound interest formula. A equals P times 1 plus R over N raised to the power of N times T. So I have A equals P equals R equals N equals and T equals. They told me that I deposited $6,500. So that's my principal in a savings account that has a rate of 7%. I'm going to take that 7 and divide it by 100 to get it in percent form, which is 0.07. They told me that they compounded it monthly. That's going to give me my N. There's 12 months in a year, so my N is going to equal 12. How much money will you have after 4 years? So my time is 4 years. I'm looking for how much money I'll have in the future, so I want that A. After I figure out how much money I have, I can also find the interest after 4 years. So I have my future value is the principal, $6,500, times 1 plus the rate, 0.07, over N, so that 12, raised to the power of 12 times 4. When I plug this in the calculator, I have 6,500. Open up the set of parentheses, 1 plus 0.07 divided by 12. I hit the right arrow to get out of the fraction, close the parentheses, hit that a to the power of b to get up in the exponent, open a set of parentheses, 12 times 4, close my set of parentheses to say I'm done with the exponent, and hit enter. So that gives me a future value of 8,593.350206. Now we know they could ask us to round to the nearest cent or to the nearest dollar. In this example, let's round to the nearest cent. So that 0 tells us to leave that 5 alone. So the future value would be $8,593.35. When I'm trying to find the interest, remember the interest is the future value minus the principal. So we just calculated the future value, and I need to subtract out that principal of $6,500. So if I do that, I'll have my $8,593.35 minus $6,500, which tells me that the interest was $2,093.35.